Did you know that nothing can have a probability of 1 in 5 million? Nothing! Because there's no 1 in 5 million. There's only a 5 and 6 zeros. Hey, we're going to talk probability here today. And I hope you love it, because probability has some very cool applications, as you'll see. But I need you to do me a favor. I can't make you. I'm not there. But I'm going to ask you nicely. Please, when I'm done with this, pause the video and just take 2 minutes and write down ways you have heard or seen probability used in the real world. Now, if you're in the classroom, I'd have you share that with a partner. Or if you have somebody nearby, hey, even if it's your dog, just share with them what you thought about. And then, yeah, if we were in the classroom, I'd have you share with the whole class. But the ultimate idea is this. The big question I want us to get at, and I know you will not be surprised, what shall we mean when we say the probability is? So it's important for you to just get it in your head, just some of the common uses, so that when I start talking later, you have something to draw on. Okay, I'll shut up, pause the video, write some things down, and then come back. So some things that I've seen when I was preparing this PowerPoint, they might say something like a weather thing. The chance of rain is 35%. That's probability type thinking there. The chance of rain. But what do we mean by chance? Or you've probably seen things like this before. Heavy cell phone users are subject to a higher risk, a higher probability of benign and malignant tumors of the salivary gland. But what do we mean by a higher risk or a higher probability? Or you're more likely to get struck by lightning than to win the lottery. We hear this kind of a thing all the time. The word likely. You have a greater probability, we might say, to get struck by lightning than to win the lottery. But whatever we say, whether we say chance or risk or likely, we're really talking about probability, and I want to get at what does any of this mean? Or how about this? He may report it as 1 in 4 have fatty liver disease. Does that mean that if you just happen to be in a group of 4 people, that one of you has fatty liver disease? What does it really mean to say 1 in 4? And then on a related but not equivalent note, the odds of winning. What do we mean when we say odds of winning? And how are any of these related to probability? And what does it all mean? And the thing I'm going to bug you about forever on this is if you say that, well, instead of probability, I'm just going to say chance or risk or likely or odds. If all you do is replace the word probability with chance or risk or likely, you have not explained its meaning. You've just changed the word, and the same question will exist. What do you mean by chance or risk or likely? So let's get at it. First of all, there's 3 kinds of probability that you should be aware of. Kind number 1 is theoretical, or the classical viewpoint. Here's what we mean. Suppose you had a game with a spinner, and on that spinner there's 8 equal areas, and we talk about the probability of spinning a 6. And you've probably heard this before, and you're going to see it a lot throughout this module or the next couple of modules, that when we talk about probability, we're going to talk about favorable outcomes divided by total outcomes. And so, in theory, we would say something like this. The probability of spinning a 6. Well, notice that this spinner has 1 space with the number 6 on it. So in the context of this problem, the probability of spinning a 6, getting a 6 is the favorable outcome, and there's 1 space with a 6 on it. But there are a total of 1, 2, 3, 4, 5, 6, 7, 8 possible things that could happen. The total number of outcomes is 8. You could get a 1 or a 2 or a 3 or 4 or 5 or 6 or 7 or 8. So we would say that the probability of spinning in a 6, the probability is 1/8. But what does that mean to say the probability is 1/8? And don't say, well, it means the chances are 1/8. What the heck does that mean? The chances are 1/8? And don't say it's likely to get 1/8 or 1 out of it. What do you mean by that? So here's what it means in theory. Are you ready? In the long run. What I mean by in the long run is if I was to spin this spinner over and over and over and over again for the rest of my life, and every time it stopped spinning, I recorded what it landed on. I recorded a 2, a 5, a 1, a 7, a 6, an 8, a 2 again, a 3 again, a 4. I wrote them down. For the rest of my life, I spin the spinner, I write down what I see, I write down what I see, I write down what I see. So I like to say this, I've done this a bazillion times. And then just before I die, I look back at all the results and I count them up. What I would find is 1/8 of the bazillion is the number 6. Hey, by the way, if you wanted to, you could think about 1/8 as 0.125. Or you could think of 0.125 as 12.5%. And so what I would say is that of those bazillion times, in theory, if I spun the spinner a bazillion times, 1/8 of the results would be the number 6, the spinner landing on a 6. 12.5% of the time, it would be the number 6. That's what probability means. In the long run, do something repeatedly, and 1/8 of the results, 12.5% of the results, 1 out of every 8, on average, would be the number 6. If you equally distributed all the results, you could put the number 6 in with a group of 8, the number 6 with a group of 8, the number 6 with a group of 8, and you could do that for the bazillions and bazillions of results. You would see this ratio of 1 number 6 for every 8 outcomes. Theoretical in the long run. All right, there's another way that we do probability. It's called experimental. And experimental is just what it says. You do an experiment and you look and see what happens. And so here's an example. Suppose I wanted to talk about the Phoenix Suns because I'm missing sports right now. And I can think of their season. This is before they suspended the season. I can think of their season as an experiment. That they've won 26 games and lost 39. Well, 26 plus 39 is 65. So there's 65 games played. So the total number of outcomes is 65. And of those 65 games, the favorable would be the number of games they won, which would be 26. And so I would say the probability of the Suns winning is 26/65. And I'm typing that in right now. It's nice. It comes out to be 0.4, so 40%. So the Suns have won 40% of their games. Oh, duh. It's right there too. And so we could say the probability of the Suns winning a basketball game is 40%. That is, if they play basketball games a bazillion times, that they'll win 40% of the games. That's the probability. But now this is just experimental in the sense that that's not a theoretical thing. That's just based on what actually happened. It's based on collecting data, in this case wins and losses, and just looking at the data and seeing that they've won 40% of their games. Thus, the probability, experimentally speaking, is 46%. And then there's this one, subjective. That's when people just kind of say it from their gut. Well, I believe it's their opinion. It's their feelings on a topic. And we see this all the time now. What's the probability that we will return to school this semester? Well, we actually now know it's 0. But say a few weeks ago when all these decisions were being made about the situation with the pandemic, and we might have said, well, what's the probability we'll return to school? And in what you see, I Googled this one. So back on April 2nd, the governor of Minnesota said, relatively slim chance. That is a subjective personal viewpoint. That was not based so much on collecting explicit data and computing a percentage, or it wasn't based on the theory of if we have the COVID-19 pandemic over and over and over again a bazillion times, then It's not on that. It's just the governor saying, hey, it's my opinion. It's based on some things I'm seeing. I'm listening to my advisors. I'm listening to doctors. I'm looking at the data, whatever. But this is just the governor saying, relatively slim chance. We call that the subjective viewpoint. So that is what probability is about. That is what it means. We will mostly focus on theoretical. We'll do some experimental, but mostly we'll be living in the theoretical world. And so I want you to get to this place where you can talk about in the long run. All right. So what I'd like you to do is this. Pause the video. Actually, I'm going to stop the video after this. And I would like you to just work on these items here. In the case where you can actually figure out the probability, do it. But in some of the cases, you will approximate or you'll be a little bit on the subjective side. That's okay too. But remember, what we're talking about is thinking about favorable outcomes. That's the thing that we're focused on in that experiment, divided by the total number of outcomes. And then you can report that answer as a fraction, or you could determine a percentage for that same probability. So take a minute, think through these. I'm going to make another video that gives you my thoughts on these so you can kind of check your thinking. Have fun.